All right, hello and welcome. We are going to be working on the notes for Unit 2, Part A. So I'll put Unit 2A there. And the first thing is that we're making a copy of this. And I'm going to put in here copy of. It already has the copy of. Excellent. And there we go. All right, we're starting with our original copy of this. I'll close the first one. All right, so what we're looking at is these two lines cut by a third line that goes across both of them. The two lines are very interesting when they're parallel, and the third line, when it goes across them, we call that a transversal, kind of like it's a bridge across the two things. What winds up happening is we either have vertical type angles where things are congruent, or we have linear pair type angles or supplementary where they're going to be adding up to 180. So I know that A and B add up to 180. I could also say like A and C add up to 180, F and E. So F plus E equals 180, F and G. All of these are making a straight line whenever you look at them. So we have A and B, A and C, F and E, F and G. We also have B and D, E and H, G and H, C and D. All those are making straight lines. Vertical angles, we have BC, AD, FH, EG, or G and E. But now we have these other words. So like the same side interior, alternate interior, same side exterior, alternate exterior, and corresponding. And what does all that mean? Okay, so let's talk about these same sides, alternate sides. Same side is referring to this bridge line here, the transversal. Is it on the angles that we're talking about on the right side or the left side? And then the interior versus the exterior is talking about the space either outside those parallel lines or inside. Interior is in between and outside is there. All right, so let's see what happens when we're same side interior. That means it's like D and E. And notice I have one big one and one small one. And what's interesting to me is that E and B are like copies of each other. So though B and D add up to 180, which also means that D and E add up to 180. So those are a supplementary relationship. Same side interior is blank plus blank equals 180. Alternate interior would be, and that's like E and D. And the other one is C and F. You should write those in there. Okay, alternate interior is when you have one on each side of this bridge line, the transversal line. So it's like saying D, and then we're going to have one on the other side, but it's interior. Now here's where it gets a little bit interesting, is that when we say alternate interior, we don't mean D and C, because those are on opposite sides. But we want one from the top group of angles and one from the bottom group of angles. For each of these angle pairs that we're looking at here to fill in, you're choosing one from the top group and one from the bottom group. So for alternate interior, if I'm D, the other one from the bottom group that's inside but on the opposite side of the transversal, so we have D, the other one would be F. So that's like D and F. Another one there would be C and E. C and E. Cool. So C and E. And these are actually equal. Let's take kind of a break here and start talking about how the measures of these angles work out. Notice that I have small angles and big angles. All the small angles are going to be equal to each other. So this E equals 58 degrees. The ones that match that are G, so that's a 58. And let's see what else is small. B and C are also 58, so that's 58, and C is also 58. Then we have all the big angles. Those are 122. So A is 122. Across from it is D is also 122. And then I have F here is 122. And H is also 122. Okay, so we got a lot going on there. with all these different angles. But it's either one measure, it's the small measure, or the big measure. And now let's start looking at the rest of these angle pairs. So same side, exterior. Same side means that we're going to be on let's say the right side of the transversal, and then we'll do the left side next. So we'll do the right side, but outside those parallel lines. So I need one from the top group, one from the bottom group. The outside from the top group is B, and its matching pair on the same side but of the transversal, but outside the parallel lines is H. So B and H are same side exterior. Perfect. And so that means those, we have a B and an H. Notice that B is the little one and H is the big one, so that means those are adding up to 180. They're not the same. Alternate exterior. Let's see, what is alternate Oh, let's finish this. B and H are same side exterior. A and G are also alternate exterior. Okay, alternate exterior, again, we have on either side, alternate means one from the right, one from the left. Exterior means one from above those two lines and one from below the two lines. Okay, so let's say I were to choose A. So A is above and left. So alternate means now I got to go right, and exterior means I need to be on the outside again, outside of those two parallel lines, which means H. So A and H is a pair of angles that matches that. And then the other one would be B and G. Now notice this relationship. We have A and H, big angle and big angle. B and G, little angle and little angle. So we have matching pairs that are equal to each other, or one equals the other, so it makes it congruent. Corresponding. This is probably the easiest one, and I left it to last here, but you think like, oh, it doesn't sound like any other ones. Corresponding just means like same side, same location. So when I'm looking at E and I see from the bottom group that E is in the top right, I'm going to go up to the top group and say, what's in the top right? It's B. This is the one that you have the most pairs of, because we're going to have 4 pairs. E goes with B. F goes with A, because those are both in the top left. G goes with C. And D goes with H. So we'll say H and D. And because these are all kind of in that same location, they have that same matching measure. So those are going to be congruent. All right, let's kind of make this a little bit more colorful, and also just look at it with more complexity here, because I have 2 red lines, but now that are the parallel lines, you can see there. But now I also have blue lines that cross all the way, and I have, how should I say this? I have a couple of right angles in there. All right, so this is a drawing. I'm going to click on editing it for a second. And so let's start marking some like vertical angles and linear pairs. So I'm going to say, here's a vertical angle at 3. And here's another vertical angle at 6. So there's a pair of vertical angles. What about a linear pair? Okay, a linear pair, I could say 14 and 13. So I got to duplicate that or copy and paste it. So now I got 14 and 13. Those are linear pair. Complementary. Complementary means 2 angles that add up to 90. Well, 6 and 5 are going to add up to 90 right there, because they make a right angle. Supplementary, 2 angles that add up to 180. Let's do 7 and 8 down here. So there's a pair of supplementary angles. Corresponding, all right, let's find 2 angles that are in the same location. So let's say, all right, how about 8 and 3, because those are both in the top left location and they're equal. Notice that one angle can have more than one relationship depending on which other angle it's looking at, which that's the best part, that you can see more than one relationship going on. Okay, alternate interior. There's only really one alternate interior that I can see right away, and it's 6 and 8. So this angle 8 is relating to like 3 different things. So is angle 6 there. Alternate exterior. This is a good one. So let's try angle 5. What would be alternate exterior to 5? Well, if I go down this blue line, but on the other side, I'm going to hit angle 12. So there we go. We got angle 12. Same side interior. Okay, same side interior. That would be like both on the same side of the blue line, but both inside the red lines. So that could be angle 2. And then we got to copy and paste this for 13. So those are same side interior. Okay, same side exterior. I'm going to come over here and I'll put 11 is exterior. Well, what would be the same side of the blue line but outside the red lines? And that's going to be that up there, angle 5. So you have all these kind of matching relationships, but they're color coded so that you can see like, oh, there's the reds kind of match together, these hot pinks match together, this kind of medium blue, this purple, the dark greens, the light greens, the brown, the orange, and these light pink here. So those are all kind of matching pairs there. All right, let's go back, let's edit this, and let's move it so that it's all in picture here. Awesome. Okay, so now I want to try and match more vertical angles. We have 3 and 6, 2 and 5. Well, 8 and 10 is a pair of vertical angles. So I can go to 8 and 10. Those are a pair of vertical angles. And once you get at least a couple from these drop downs, 12 and 14, those are vertical angles. They're opposite each other. And we got 13 and 11 would probably be the last one to look at there. Okay, linear pairs. So linear pairs when 2 angles put together make a straight line. So we have 13 and 14. We got 12 and 11. You'll notice that a lot of these are kind of like right next to each other in the numbering. We have 8 and 9. Oops. So 9 and 8. And we also have like 7 and 10. Perfect. And so complementary now, angles that add up to 90. We already got one pair, 5 and 6. So we'll mark that one 5 and 6. And let's do another pair. How about 2 and 3? Those make a right angle corner. And now I'm going to do something that's a little bit different. Notice that 2 and 5 are the same. So I could swap out the 2 with the 5, and I could say 2 and 6. It's like a substitution. If I take the 5 out and replace it with a 2, because those are both vertical angles. I could have similarly said like 2 and 3. I did say 2 and 3, but I could have said 5 and 3. Because that 2 and 5 are swappable. So are the 3 and 6. So any kind of combination of one of those and one of those is going to work. Supplementary. Ooh, this should say add up to 180, not to 90. I'll fix that on the original notes for you all. Pardon that minor typo. Supplementary. Things that add up to 180. So we're going to say like 13 and 14. A lot of times these are, let's do like the brown one, same side interior. So we can use this information for more than one place. So 2 and 13, 2 and 13, 2 and 13 is a pair that does that. And I'm going to have something edited for your original notes here. I'm going to copy and paste this plus an amount. So we can do it like 3 times, like that. Cool. And we'll make this a little bit smaller. All right, we're going to make those edits for the original one for you, just so things fit in here a little bit better. And so what are 3 angles that add up to 180? I see 2, 1, and 6 make a straight line. Now, you could argue that's supplementary or not, but the idea that I care about is that you know that those three, when you put them together, make a straight line. Okay, let's just try and do one more pair from each of these, and then we'll end this part of the video there. Then we'll do a part 2 of the video in the as an addition to this. So corresponding. All right, let's see what we wrote up here. We said 8 and 3 are corresponding, which we already marked. But we could also say 6 and 10. Those are both small angles in the same location. So 6 and 10, and those are congruent to each other. We could also say 12 and 2. And so 2 and... That's our bell for the day. And we have alternate interior. Let's see what we marked for alternate interior. We got 8 and 6, which we already marked. We could also mark 2 and 14. And alternate exterior, we got 5 and 12. Those aren't marked yet, so let's mark those. 5 and 12. And then same side interior. So we have 2 and 13 is already marked. What else do we have? We don't really have much else. But we do have a 6 and a 9. And that might be it. You might not have a third one. Let's get that to 9. And we'll do the 6. And same side exterior. We said 5 and 11, which is already marked. And that might be the only one because everything else is kind of broken up into pieces. So for example, 7 here. Oh, 7 and 3? Yeah, 7 and 3 is probably the only other one that I see right away. Let's get back to 7 and 3. So we're looking at this idea of like matching up these different things here. So work your way through. Try to figure out what those angle pairs are, whether they are equal to each other. So all these vertical, all these corresponding, and alternate interior, and same side exterior. No, same side exterior. No, an alternate exterior. So the alternates tend to be the same. The corresponding are equal. The vertical is equal. But then we have linear pair, supplementary, and other ones that add up to 180. And then we had, this one had a few complementary angles because of those right angles included in there. All right, that's the end of like the first half of this video, but we'll just attach it to a second half. Part of this Unit 2 Part A notes, and this is a part where we have a lot of equations going on. We're going to use math.new to solve equations whenever we need. But sometimes you'll find that we don't even really need to solve an equation because it's just the number equals a number. For example, this first one here. I see that these two angles are in the same location, which means that they're corresponding angles, and they're just congruent. So it's that simple. They're congruent. What's the question mark equal? 89. There's no work to show when you already have a measure and it's equal to it. Okay, so let's go to the next one here. Just straight down from it. It says that I have these two angles here. Now I look at these two angles and I notice that they make a linear pair. And a linear pair is when two things add up to 180. So I'm going to say something plus something equals 180. And once I've said that, now I can kind of set up that equation and work out what I have. If I were to write that into a whiteboard, it's like this one here where it says blank plus blank equals 180. And so I'll just call it x plus, what was the other number? Let me go back and check. It was 82. X plus 82 equals 180. In reality, this could be done as mental math, but if you're trying to work your way through it and track your work, this is helpful to do. So we find out that we just subtract from 180 and we get x equals 98. I'm going to screenshot that work and we'll scale it down so it fits in that size of the box. So that goes into my clipboard. And I should be able to paste it here. There we go. So it's pasted in there. I'll make it a little bit smaller. It doesn't need to be extra small, just a little bit smaller. Okay, for this next one, I see that I have two parallel lines. we would label this relationship as same side interior. They're both on the same side of that transversal bridge, and they're inside a pair of parallel lines. That relationship is two things add up to 180. So then I can say, all right, that's the same thing as before. The difference is instead of starting with 82, it's going to be a 50. So I'm going to change that 82 to 50. So now I can subtract 50 from both sides. And 180 minus 50, super straightforward. X equals 130. So again, I'll screenshot this, put it into my notes for a little bit of work. Awesome. Okay, now I have two angles, and it's a little bit hard to tell, but I'm going to do something that helps me demonstrate how I know what this is. I'm going to trace through and make copies of angles. So one way I can do that is if I actually screenshot this 79. You can do this on your own devices as well, but I see a 79 here. I'm going to try and mark all the other places that are 79. So 79, let's make it smaller so it kind of fits into these pictures, is also here, right across from it with a pair of vertical angles. And then I could copy and paste that and make one here because those are also corresponding. And then this question mark is just 79. I could count that as my work. I don't necessarily need to show all the calculations. But it's helpful to do it that way because then I get that it's a congruent relationship. So this is going to be a congruent relationship, and the measure is just 79. So we did a bunch of numerical calculations. Now we're going to do calculations that work with algebra. Okay, so as we look at these, we're trying to determine, are they equal? Do they add up to 180? What's the situation? So for this first one, I see two angles that make a linear pair. One of them does have a measure, but it's marked in the picture with a square box instead of numbers. The square box means the right angle corner, so that's 90. And then the other angle is 10x plus 10. So this relationship is two things add up to 180. And I'm going to go into my whiteboard here that I had set up. I'm just going to reload it. And I'll say that I have 90 plus 10x plus 10 was the other piece equals 180. Now, if you weren't sure how I came up with that, what I was doing is I have box plus box equals 180. So I was filling in what those boxes are. In fact, I'll kind of restart it, show it even more clearly. So one of the boxes was 90, and the other box was 10x plus 10. Now I got things that I can combine. I could combine this 10 and 90. Those go together. And then I could get x by itself. First, I'll subtract 100 from both sides, but I'll do it on the left side so it kind of matches up with the 100. Negative 100 there. That'll make a 0. And on the right side, it'll make an 80. You might already know what the answer is because I'm going to divide both sides by 10. And that's going to give me x equals 8. Awesome. So there's all my work to calculate, or not calculate, but to solve for what x equals. Capture that. I'm going to go back to my copy of the notes, paste it in. There we go. But that should be, it's a little big, but that's okay. Make it a little bit less big. Let's look at this next picture. So now I have two angles that are inside of the parallel lines and on the same side. Those two add up to 180. So I'm going to say blank plus blank equals 180. I'll go back to my digital whiteboard, and I'm going to go back to the original line because I have two things add up to 180. And the two things are 50 and 31x plus 6. So I have 50 and 31x plus 6. Something that's neat that you can do with graspable math, but I haven't done a lot so far, is you can actually drag two things that can be combined on top of each other, and it will go ahead and add them together for you if you didn't want to put them next to each other. And then I'm going to do a negative 56 on both sides, adding a negative 56 to make a 0. And on the right side, it makes 124. Now I got to divide by 31. It should go in to make a nice friendly number, and it does. It says x equals 4. I'm going to zoom out slightly just so I can get all of my work in there. There we go. Capture it. I'll put it in the notes into my copy here. We're still things that add up to 180. Paste it in there. Nice and easy. We have a couple more, but these are completely different. It says find the measure in bold. What that means is I have to solve for x, but then I got to figure out by plugging it back in what the measure is going to equal. So this is a congruent relationship because we have vertical angles. Two things are equal. So I'm going to say 13x plus 13 equals 15x minus 5. Let's see how those two things work together. So I have 13x plus 13 equals 15x minus 5. I want to get the x's together and the constants together. So I'm going to start by adding 5 to both sides. That will give me a 0 with the negative 5 and 5, and an 18 with the 13x, or the 13 on the other side. Then I'm going to add a negative 13 to both sides. Oops, let's change that, typo. A negative 13x to both sides. So that means I'm going to now get a 0 over there, but a, let's go back, go back, and then let's try this again. I did something wrong to it. So negative 13x to both sides, and that's going to combine here. Got to grab the minus sign to put those together. Put those together there. Cool. And then put the 15x and the minus 13x together. In the end, now I have 2x minus 13. Oh, something's wrong. Mr. Butler's doing a few wrong things here. So I'm going to go all the way back to this last line. Put these together. And then equally add negative 13x to both sides. Make a 0. Make 2x. Now I'm getting it right, and now I'm going to divide by 2, and I get that x equals 9. I know that x equals 9, but what I want to know is what's the measure of one of the angles. So x equals 9, but I'd have to do 15x minus 5. So all I do is I type in here, new equation, but it's 15 times 9 minus, 2? Let's double check. 15x minus 5. So 15 times 9 minus 5. That calculates to, let's see what this comes out to. 135 minus 5, so it's 130. So here's my whole work, solving for x and calculating what the angle is. And we wind up seeing that it's 130. In fact, it would have been 130 for both of these because they're congruent. One final one, and then we're done. Looks like it got to the next page. We have two angles, but I want to do a little bit of duplicating and kind of copying here. So I see this 20x. I'm going to take a picture of that 20x and copy and paste it back into the picture into other angles that are also equal to it. So I'll capture that, paste it, make it a little bit smaller so it fits into my picture. This one is also 20x, and this one is also 20x. Those are all corresponding angles. They're all equal to 20x. What that does for me is it shows me that these two angles here far left are going to make a line. And if they make a line, that means that they're going to add up to 180. So I'm going to say that those are supplementary. And now I'll do my supplementary equation. Go back to the top where it says box plus box equals 180. One of the boxes was 20x. The other piece was 19x plus 6. So that's 19x plus 6. Okay, so we got a lot going on here with big numbers, but that's okay because this calculator will handle it for us. Let's subtract 6 from both sides to get the x by itself. I got 39x equals 174. I'm really curious how many times 39 goes into 174. Let's find out. And it says 58 over 13. I want to make sure that I did everything correctly. It's 4.462. So it says that that is 4.462. And if I were to actually plug it back in to one of these equations, let's see what I would get. 20x, 19x plus 6. Everything's looking correct there. So we want to plug it into 19x plus 6. So I'm going to say 19 times a box plus 6. But here's one of the neat things is you can actually drag a value that you already used to solve and substitute it in there. So you don't have to necessarily rewrite it. And that winds up being about 90.769. Kind of interesting how it's a lot of work just for that final answer there. So I'm going to move these next to each other, take a picture of them next to each other. There we go. We'll put that in for our last piece. And that's it. That's all the work done. Thank you.